For most of the 20th century, a central belief in neuroscience was that you are born with all the brain cells you will ever have. The adult brain was seen as a fixed, static machine, a circuit board where connections could be strengthened or weakened, but the fundamental components were set in stone. In the 1960s, a scientist named Joseph Altman injected radioactive markers into adult rats and saw something impossible. New cells were forming in a very specific part of the brain. His work was largely ignored for decades, a whisper against the roar of established dogma. That specific part was the hippocampus. If you could peel back your temporal lobe, you'd find this seahorse-shaped structure tucked deep inside. It's your brain's cartographer, responsible for forming new memories and navigating the world. Within the hippocampus is a region called the dentate gyrus, which acts as a kind of neural nursery. This is one of the very few places in the adult mammalian brain where the story of cellular birth, or neurogenesis, continues long after you've grown up. So how does it work? It begins with a neural stem cell, a blank slate with the potential to become anything. This stem cell divides, creating progenitor cells, which are slightly more specialized. Think of it as a worker choosing a trade. These young cells, called neuroblasts, then embark on a perilous journey, migrating through dense neural tissue to their final destination. Once there, they extend axons and dendrites, plugging themselves into the existing network, hoping to become a fully functional neuron. But here's the catch. Most of them fail. The vast majority of these newborn neurons die within weeks. Their survival depends on a simple principle: being useful. To survive, a new neuron must integrate into a network that is actively firing and processing information. This is where learning and experience become critical. An animal in a complex, stimulating environment will successfully incorporate more new neurons than an animal in a barren, empty cage. It is the ultimate use it or lose it scenario at a cellular level. Why does the brain even bother with this risky process? One leading theory is called pattern separation. Your hippocampus needs to distinguish between very similar memories. For instance, remembering where you parked your car today versus where you parked it yesterday in the same parking lot. The old neurons might store the general map of the lot, but the fresh, highly excitable new neurons are thought to be crucial for encoding the fine details that make today's memory unique from yesterday's. They are the ink for subtle distinctions. But this constant addition of new cells comes with a surprising consequence: forgetting. As new neurons integrate into the hippocampus, they don't just add information, they actively remodel the existing circuits. This rewiring can destabilize older, less accessed memories, essentially writing over them. This might be why we experience infantile amnesia. The high rate of neurogenesis in our very early years could be clearing out old memories to make way for new learning. Forgetting isn't just a failure of memory, it can be an active process of making space. The rate of this process isn't fixed. You can influence it. Aerobic exercise, like running, is one of the most potent stimulators of neurogenesis. It increases blood flow and releases growth factors in the brain. Conversely, chronic stress and sleep deprivation flood your system with cortisol, which is toxic to the dentate gyrus and dramatically reduces the birth of new neurons. Even your diet matters. Flavonoids found in blueberries and dark chocolate have been shown to support the process. This entire story isn't just about memory. It's also about mood. One of the leading hypotheses for how antidepressants like SSRIs work involves neurogenesis. It's not just about instantly changing serotonin levels. The drugs seem to work over weeks because that's how long it takes for them to stimulate the birth and maturation of new neurons. These new cells may help build more resilient neural circuits in the hippocampus, which is heavily involved in emotional regulation, helping to break cycles of negative thought. So, the brain you have today is physically different from the one you had last year, and even last week. It is a dynamic, living tissue, constantly replacing some of its most critical components. Adult neurogenesis is a profound reminder that you are not a finished product. Your experiences, your actions, and your habits are physically sculpting your mind, neuron by neuron, moment by moment. The person you are is in a constant state of becoming.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.